In this lesson, you will learn how to solve exponential equations. When solving exponential equations, you first want to try and make both bases the same, because if you do that, it's so much easier to solve it. If you can get the bases to be the same, then the bases can cancel out and you would make your exponents equal. But sometimes you cannot get the bases to be the same. If you cannot get the bases to be the same, you need to rewrite the equation in log form and then solve. So let's go ahead and get started. Number one, I have 3 to the x equals 27. I can rewrite 27 in terms of base 3. 27 is the same thing as saying 3 to the third power, because 3 times 3 times 3 is 27. Now that the bases here are the same, they would cross out. You can just make your exponents equal. So x would equal 3. Exponential functions, for your variables, you can have both positive and negative, so you do not need to worry about checking your work unless you just want to. All right, number 2, I need to make both of these have the same base. I think we could do 4 is what I see, or even 2, but 4 is what I would do. But if you don't see, just use the log form way, which I'll show you how to do that in a few minutes. 4 to the third power is 64. But then there's an x here, so just put the x right next to that. 4 to the second power is 16. Now that the 4s are the same, make your exponents equal and solve. So divide by 3, and you will get x equals 2 over 3. For number 5, I can rewrite this also in terms of 5. So I have 5 to the x equals 1 over 25 is the same thing as saying 5 squared. Now, you can't cross them out when the 5 is in the bottom, but I can use the properties of exponents to bring this up here. So I would have 5 to the x equals 5 to the negative 2. Remember, when you move your exponent up and down, you must change, when you move a base with its exponent, you have to change the sign of the exponent. Now, the 5s are the same, so I can just say x equals negative 2. All right, number 4, this is a 9. I know I can make that a 9. So we have 9 to the 2x plus 1 equals 9 squared. 9 times 9 is 81. Make your exponents equal. 2x plus 1 equals 2. And then just solve this. So move what's around the x first. Subtract 1. 2 minus 1 is 1. And then divide by 2. So you will get x equals 1/2. Okay, number 5, there is no way I can get this to be the same base, so I have to rewrite this in log form. Remember, to rewrite it in log form, you write log and then your base, which is 84, and then switch. So 70 equals x. And there you have it. This you can enter into your calculator using that, either the change of base formula, which would be log 70 divided by log 84, or if you have a more advanced calculator, which you should at this level of algebra, like a TI-84 plus is what I recommend. I would do alpha, window, and the log base is the 5th option. So you would put in 84 and then put in that 70. And for these, we're just going to round to 2 decimal places. So this would be 0.96 to 2 decimal places. Okay, so for this one, I used a log because it was a number, but remember the inverse of an e is ln. So I can't get this to be an e, but I can rewrite it in log form. So this would be the natural log of the base, which is e. We never write the e there. So just write your 200 equals your exponent for t. Now I need to solve for t, so divide by 4. Some teachers would be okay with you leaving your answer like that. Others would tell you to round that. So you would enter ln 200, there's an ln button, divided by 4. And if I was to round this to 2 decimal places, I would get 1.32. Okay, the last one would be number 7. I can't write this in log form if I have this 1,000 here. So divide by 1,000 on both sides. So you get e to the 0.09t equals 5. Then now write it in log form. So this is again a natural log. I don't have to put the e. 5 equals 0.09t. Divide by 0.09 on both sides. And I'm going to go ahead and enter that. Natural log of 5 divided by 0.09 to 2 decimal places. I'm getting 17.88 equals t. Now, it's important to tell you this. If you don't want to write these in log form, I could just bring a log on each side and use the properties of log to solve it. For example, if I was to do number 5 like that, I would do log 84 to the x equals log 70. If I bring it to one side, I have to bring it to the other side. Now, the properties of log say I can bring that in the front. So this is x log 84 equals log 70, then divide by x. Some of the problems in my notes, I have this method, so I wanted to expose y'all to both. If you enter this in your calculator, you will get the same thing. Okay, so just two different ways of doing the same problem.